Good morning. This is a review for chapter 26, so I hope it puts in perspective all the words I went through that were sent to you by Mrs. Kelly. So I want you to open your book, please, to page 663, just to show you the pictures of the two different kinds of telescopes. And you remember that. The first one is a refracting telescope and the other one is reflecting. And remember, you want to get them straight. Refracting, a telescope that uses a set of lenses to gather and focus light from distant objects, whereas a reflecting telescope uses curved mirrors to gather and focus the light. And we also have a third telescope, a radio telescope, which you could read about in your book. And that's also very important to get distances of some of these galaxies moving away. Now I want you to turn to page in your textbook, page 668, because I think we have to explain a little bit more about your perihelion and aphelion, and also about the rotation and revolution. So, first of all, rotation, and I like to give you that little funny phrase of rotate around an axis, and that takes 24 hours. Where the revolution is revolution and around an orbit, the Earth going around the Sun. And when we talk about all the other planets, they also have an orbit going around the Sun. Ours happens to go around in 365 some days. Now, if we are in an ellipse going around the Sun on page 668, sometimes we are closer to the Sun and sometimes we're further away from the Sun. If you look at your roots, aphelion, aph means away from in Latin, and helios means sun, away from the Sun. And sometimes we're closer to the Sun, perihelion, paris meaning close, peri meaning close, and helios, sun. Now that's going to be very important for chapter 27 because that was how Kepler defined how fast these planets are moving around the Sun in their aphelion or perihelion orbit, because it gives you the speed of the different planets. So those are the words I wanted you to go through. You also know calendar and how to measure those things in day, year, and month, and so forth. I'd like to jump now to page 671. We talked about standard time, and I said you have these different periods down here. You probably can't see me pointing to them, but they're 15 degrees apart. And you have 15 degrees apart for standard time, 15 times 24 hours in the day, give you 360 degrees. That's the circumference around the globe. So here we are in Eastern time, then you have Midwest time, and you have then Mountain time, and you have Pacific time, and you have Alaskan time, and so forth. Now, they're not perfectly 15 degrees apart. You zig-a-zag around so that you can get parts of your city or state in the same time zone. I have trouble speaking today, but that's all right. You can understand what I'm saying anyway. So that's why the time zones are that way. We now in the United States have pushed this idea of daylight saving time, and we started very early compared to other countries which don't start it so early in the season. We start ours in April. I want you now to turn the page in your book, because that's the other thing we wanted to explain, and that's on the seasons and so forth and equinoxes. So if you look at that, equinox is when the sun hits directly on the equator. See the equator here? So that's equinox, the moment that the sun appears to cross the celestial equator. Okay? There we are. Wonderful. Now when does that happen? Twice a year. We just had ours on March 21st. The sun hits right here. Feast of St. Benedict. Wonderful. And it's moving. And finally, about June 21st, it hits here, the Tropic of Cancer. All right, that's the highest that the 90-degree angle moves in our hemisphere. But remember, we have seasonal lag. We don't have the hottest temperature in Washington, D.C. on the 21st of June. It takes a month or so. We have our hottest weather at the end of July, sometimes in August. Okay, and then the sun moves down after the 21st, goes down, 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 and hits the equator then. When does it hit the equator? It hits the equator exactly on September 23rd or 22nd, depending upon leap year. And that's called the autumnal equinox. And then it goes down, 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 down. And eventually it hits here the Tropic of Capricorn on December 21st. We don't have our coldest weather here in Washington on December 21st. We usually have it at the end of January, beginning of February. Why? Seasonal lag. It takes that time for the planet to cool off longer. So now you have those words all on your page here. Word 27, equinox. Word 28, autumnal equinox. And then vernal equinox, word 29. And you have all the dates there for you. We've had this before in earlier chapters. And then on the back of my sheet, you have this wonderful thing called solstice. The time that the sun hits the highest for us, June 21st, or lowest for us, December 21st. So obviously, in the southern hemisphere, they have their summer when we have our winter, the reverse of these things. So you have summer solstice and winter solstice. So I hope that helps you review some of these words on this chapter. I know maybe on the calendar, whether we did yesterday and a couple of days, and I think Mary sent you all the words already now that you can do at your leisure. They stay there for a couple of days, do they? Sure. And you can do that and look at them. If I make mistakes, sometimes I do make a mistake, so I'm trying to correct this and trying to show you the things on the map. So obviously, once you finish chapter 26, we'll start chapter 27, and then I'll have Mr. Collins help me then do the words. We'll start with the words in chapter 27 in a day or two. So now you should get 4 of these. 3 of these visual things for the words, and 1 then for a review on the map. So thank you very much. I hope you're all well and thriving. So am I. Thank you again. God bless. Bye-bye.